Hello everyone, I would like to welcome you to this Computer Science 190 lab. This will be the last lab in the semester. Okay, so here's what we're going to do. Here's what we're going to do today. We're going to calculate the sum of the major diagonal in the matrix. We need to write a method that sums up all the numbers in the major diagonal in a 4x4 matrix. Okay, so that's going to be 4x4 specifically of double values. Using the following header. So here's the method we need to create: public static double sum major diagonal double m. Write a test program that reads 4x4 matrix and displays the sum of all the elements in the major diagonal. Here's an example, sample run, right? So we ask any user enter 4x4 matrix row by row. So the user types in 1, 2, 3, 4.0, 5, 6.5, 7, 8, right? So like 3 is also 3.0, right? We're just not writing 0.0 there. But essentially, it's also the number without any decimal point. 9, 10, 11, 12, 13, 14, 15, 16, and then sum of all the elements in the major diagonal is 34.5. That's what our program needs to print out. So why is it 34.5? I'm not sure if you know, but the major diagonal can be. Hold on. So if that's the matrix, right? The major diagonal is considered to be this diagonal. So it goes from top left corner to the bottom right, okay, and this is considered to be the minor diagonal, okay. So in this particular case, we're talking about the major diagonal, but for the rest of the exercise, something I want you to do by yourself is actually to calculate the sum of the minor diagonal. But anyway, so 34.5. How did we get this? So 1 plus 6.5 plus 11 plus 16. So 11 plus 16 is 27. Plus 1, 28. 28 plus 6, 34. And plus 0.5. Okay, so that's 34.5. As usual, in my personal opinion, and something which I developed over the practice of solving a lot of computer science problems, is it's always useful to break a big problem into smaller chunks, and when you complete one chunk of a problem, you need to test if everything works correctly before you move on. Okay, so the first part will be ask user to input the numbers, basically print this out, then create a 4x4 2D array and store user's input. Okay, then number 3 will be to process this array, right, and calculate the sum of the elements on the main diagonal. And number 4 will be print out the result. Okay, so let's start with number 1. So what do we need to do? We need to ask a user to print out the numbers, right? So that's pretty simple. We already know how to do that. Let's copy this. Okay, cool. So sorry. Okay, done that. Let's run it. Let's see if it works. Okay, it does. Perfect. Okay. Now create a 4x4 2D array and store user's input in it. Okay, so let's create. So that'll be number 2. Let's create. So 4x4 array of doubles. Okay, so we need to say double. I don't know, array is equal to u double. And then, since it's 4x4, we need to specify the sizes, like this, right? Cool, nice. So that's done. Store user's input in it. Okay, so we need to use a scanner, right? For that reason, we need to import it first. java.util scanner. Okay. Scanner input is equal to new scanner system.in. Okay, we already know all of that. So let's try to run it. Let's see if that works. First off, okay, that's good. Now we need to store user's input in it. Okay, so what's going to happen is that the user is going to type in 16 numbers, and we need to store them in this particular order. So I hope you remember from the slides from the lectures that again, whenever we are processing an array, two-dimensional array, we need to use 2 for loops. Okay, nested for loops. One would be one of which will be processing columns. The other one will be processing rows. Okay, so let's do the for loops. For int I is equal to 0, I is less than array dot length, I plus plus. Okay, and now we need this to have a nested loop for, here we're gonna use j. J is less than j is less than what? Array of 0 dot length, right? Length j plus plus. Okay. Okay, let's try to run this. Let's see if we see any errors, any mistakes. No, okay, everything compiles fine. It just doesn't do anything, right? 16 times, but at least it compiles. Next, we need to store the results. Okay, so very important. Very important to understand what I and j mean, right? So what is I and what is j? Is I columns or rows? Is j columns or rows, right? So the way it works, again, and that's something which you guys definitely need to polish your understanding of. If, let's say, okay, so let's say that's our array. So 3 by 3. So in this case, I created 3 by 3. Okay. Now, what I want to do, I want to let the user input them row by row, right? So I want the metrics to be processed in this direction. Okay. Okay. So which means that the variable in the innermost loop. Yeah. Hold on. So the variable in the innermost loop, which is j, should, since j is in the innermost loop, j is being changed, is switching more frequently, right? And that's exactly what I want to do for the columns, which means this should be j, right? So this particular variable which traverses the columns should be j, right? Now I is changing less frequently, right? So for all changes of j, I changes only once. That means I should be processing rows, right? Okay, so that's my I. That's my I. Okay, perfect. Okay, and now what are the coordinates? The coordinates would be ij in this case, ij. So like ith row and j's column. Okay, so in this case I should say over here array of I of j is equal to in dot next double. Okay, that's it. That's it. Okay, let's try to run it. Okay, let's do 10, 20, 30, 40. I don't know, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, perfect. So at least it scanned for 16 times. That's what I need. Okay, it scanned 16 numbers. Okay, so now at this particular moment, it will be very, very nice. And that's not what I'm going to do on purpose, though, but that's what I'll ask you to do a bit later. After you scanned all the numbers, it will be very useful to print out the metrics, to print out the array, the whole content of the array. Why would that be useful? Because, you know, in this case, you would definitely know that all the numbers have been stored, and they have been stored in the right positions. Okay, so I'm not going to do that now because I'll ask you to do that later on your own. But let's just, I'm kind of going to assume that I did it correctly. Okay, so that's number 2. Number 3, process the 2D array, calculating the sum of elements on the main diagonal. And that's kind of the not the tricky part, but that's something new which you probably didn't think about before. Okay, so again, if I have so let's say I have this matrix, right, and I want to process the stuff on the main diagonal. So that's the main diagonal, right? Which means I need to sum up this element to this with this element and with this element. Okay, so what do we know about this diagonal? We know that in order to sum them up, we just need to traverse the array, right? We need to traverse the whole matrix and skip all the elements which are not in the main diagonal. Okay, so in order to do that, we need to know how can we distinguish the elements which are on the main diagonal from the elements which are not on the main diagonal. Okay, and the easiest way to do that is by their coordinates, is by their location, like where I is located and where J is located. So what's I and J? So what do we know about the relationship between I and J for these three elements? In this case, it's very easy. We know that if the element is located on the main diagonal, I needs to be equal to J. For example, this guy has coordinates of 0, 0. That's 1, 1. That's 2, 2, right? So that's why what we can do, we can create another nested for loops, right? Like this thing, which is again like whenever you mess with 2D arrays, that's what you need to remember. That's kind of like, I don't know, that's what we're using all the time, like this particular nested for loop. Okay, so why don't we create one more time nested for loop? Okay, we'll traverse the entire 2D array, and we will skip all the elements for which I is not equal to J. So we will only consider the elements for which I is equal to J, and we will just add them into one variable. Okay, we'll accumulate them on the one variable sum, and that should be our answer. Okay, so let's do it again. Okay. By the way, a good question would be, so like, is that a legitimate statement? So can I use, for example, create I here and then recreate it here? Or will that create a mistake? Will that create an error? So just like as a hint, it will not create any mistakes. It will not create any errors, right? So as you can see, there are no compilation errors. It's not complaining about creating duplicate of I and J. Okay, so the good question I would ask, like if I was teaching that in class, is like why? Why is that? Anyway, yeah, so our strategy was to create a double variable called sum 0.0, okay, and over here we're going to sum up all the numbers for which I is equal to J, right, which means that I'm going to sum them up only, so I'm basically going to do sum is equal to sum plus array of ij, right? But not for all the elements, only for the elements where I is equal to J, which means that I need to have this if statement, and I need to do something like this. Okay, which means that if I is equal to J, right, execute this. If I is not equal to J, skip the statement completely, do not change sum, do not alternate that. Yeah, cool. So that would be number 3, and then I guess number 4 would like immediately come after this. We need to print out the result, right? What we should say, sum of all the elements in the nodes. Okay. Okay, is plus sum. Let's see. Okay, we need to input the matrix. Let's do the same thing. 10, 20, 30, 40. 0, 0, 0, 0, 0. So if I did it correctly, the sum should be what? 10 plus 0 plus 0 plus 0 should be 10. If I did it incorrectly, for example, I messed something up, that should be like any other number. Okay, 10.0. Perfect. I'm good. Awesome. That's it. That's it. Now, okay, so what I want you to do, I want you to do the following things. Okay, I want you to, number 1, I want you to change the code to calculate the sum of the numbers on the minor diagonal. Okay, so that was the major, right? The minor would be summing up 4, 7, 10, 13. Okay, so that's 1. And number 2, I want you to, hold on. I want you to allow the user. I want you to allow the user to input the matrix size, but it needs to be squared. Okay, so the matrices we're talking about here, I want you to allow that to be not only 4x4 but anything by anything, but it has to be square matrix, which means that like it should be either 4x4 or 5x5 or 10x10 or 20x20 or 100x100 or like 15x15 or 1x1, actually it's also possible, or like 2x2. Okay, so in other words, I want you to ask a user to input one number, right? For example, you would say something like enter the size of the matrix. Okay, or you can say enter one number which will be the number of rows and columns, something like this. Anyway, so if he types in, for example, 10, that means the matrix should be 10 by 10. If he types in like 15, that means the matrix should be 15 by 15. This thing doesn't really work, the concept of major and minor diagonals, for rectangular matrices, for not square matrices. So that's a limitation. Okay, so we do that. Change the code to calculate the number of minor diagonal. Allow the user to input their matrix size. Okay, and then yes, and number 3, I want you to print out the final matrix. Well, not the final. Print out the matrix. Yeah. So print out the user's matrix. Okay, we're not changing the matrix. So he typed in all the numbers there, right? And then I want you to print it out in this rectangular, like square shape, in this shape. You don't necessarily need to make all the columns lined up. Like here, for example, you see this like 1 symbol, 2 symbol, and then 20 is not really lined up with this 0, unfortunately, because the first column consisted of like this element consists of 2 digits. Okay, so that's why it shifted the rest of the row a little bit to the right. So you don't have to worry about that. Just print it out. Just print it out. Okay, at the end. So yeah. So now maybe I'll give you some hints. Change the code to calculate some of the numbers in the minor diagonal. Okay, so where do you have to, like, what should you do? So as a hint, what you need to do is somewhere here. Okay. To be a bit more specific, you need to do something here. Allow the user input to input the matrix size, okay, but needs to be a square. Okay, so he types in the number, right? The only thing you have to do later is basically you need to scan it first, right? So you need to scan first over here, and then you need to change the dimensions of the matrix, right? So that has to be a variable, not 4x4. And print out the result. Okay, that's easy. That's basically this, but instead of this, just print something out, and then keep in mind that it needs to be displayed in this shape, right? That's why you need to have a printout. You need to print out a blank line. You need to print out a new line between rows. So you print out the first row, you need to go to a new line. Print out second row, go to a new line. Print out third row, go to a new line. Okay, so that should be done somewhere either here or over here. Okay, hope it makes sense. I'll see you guys later. Again, you're almost done with the semester, which is very exciting. I'm sure you want to relax, you want to rest. I'll see you guys later. Have a good one. Bye bye.